Hello everybody, this is Raja again. Today I will do some square root questions where you by using trigonometric identities we can eliminate the square root. I just want to remove the square root. I don't want a square root because there is no direct way to solve a square root question unless you have a linear. Suppose you have a linear ax plus b power suppose r dx, then the answer will be ax plus b. One power increases by, then you divide by, and then you divide by derivative of this, that will be a, right? But otherwise we don't know how to solve uh, question which has a square root. Okay, and these are the I choose 7 questions. 5 of them is we will use direct square root, direct trigonometric formulas, identities, and for these two we will think which one we can use, right? They can give any question. Suppose they give you this 1 over x square minus 1, then you will put x equal to secant theta, these type of questions. Okay, let's start with this first question, and the trigonometric formulas we will use these ones. These are the 6, 1, 2, 3, 4, 5, and 6. These are mostly used for these questions where already given a square root. Okay, let's do first question, and we will use one of these identities. Okay, first question, you have given 1 plus cosine 2x and square root dx. We just want to remove a square root. We cannot write this as means this power increases by 1 over 2 plus 1, or divide by 1 over 2 plus 1, right? No, that's not the way. What we have to do, we have to use one of the trigonometric formulas, and that formula is equal to 2 cosine square, and angle is half of this. Okay, this is 2x, here will be half, and here will be square root. Okay, that square root, that is the formula I used, and this will be equal to square root 2 outside, and cosine square, and this cancel out, you will have only cosine x dx, right? And this will be square root 2, and integral of cosine is positive sine x. Don't forget c at the end. That's your first question. These are very simple, but you should know what to do. Okay, the second question is similar. I will do halfway, rest you can do cosine x dx. Here you have angle x, then the result will be x over 2 in the angle. Okay, and this will be equal to here square root is this 2, then sine square x over 2, and here dx. Okay, and this square root 2 will come outside, and this will cancel with this. Okay, this will be equal to square root 2 this sine x over 2 dx. You know the integral of sine, and this is linear, then no need to put. If this would be x square, then you have to put, right? Okay, and this will be equal to square root 2 integral of sine is minus cosine x over 2, and you have to divide with the derivative of the angle. Angle never change in integral, but you have to divide by its derivative of x over 2 is 1 over 2, and your answer will be equal to minus 2 square root 2 cosine x over 2. Don't forget c at the end. This 2 goes in the numerator, this 2 comes here, that's why you get this answer. And third one, we will use trigonometric identities to remove the square root. Sine 2x dx, and here integral. Okay, you know 1 is equal to sine square plus cosine square x plus, and you will change this into 2 sine x cosine x, and here you have dx, and this will be equal to integral sine x plus cosine x, and here will be square, and here square root dx. This cancel with this, and you have integral sine x dx plus cosine x dx, and that rest you can do. Okay, it's not done, rest you can do yourself. Okay, and now you have fourth question that is similar. This 1 minus cosine 2x, actually plus here, 1 minus cosine 2x dx. All right, you know this formula. This is 2 cosine square angle half of this will be only x, and that will be x here over 2 sine square x here dx. Okay, 2 cancel with the 2, and square root cancel with the that square, and you will get here only cosine x over sine x dx. You know how to do this one, because here beside dx is you have 1 power, here 1 power, and beside dx, if you then rest function should be in sine, then you will put sine equal to, you will put sine x equal to t, and you will get cosine x dx that equal to dt, and this whole thing must change into dt, not halfway, whole thing into dt. This is dt over t, because this will be your dt, and this will be your t, that's why this, and this now changed everything to t. You can integrate log t plus c, this equal to log, and replace sine t value, and you get the answer. Okay, now you have a fifth question. Your fifth question is that cosine 2x over 1 plus cosine 4x and square root dx. I will remove the square root here. This will be cosine 2x, and this is 1 plus 4, that will be half of this angle, that will be 2x, 2, and this will be 2 cosine square 2x dx. Oh, okay, this very simple. This equal to cosine 2x over square root 2 cosine 2x dx. This cancel with this, and this equal to 1 over root 2 dx equal to 1 over root 2x plus c. That's it. That's your answer. And now you have a sixth question, that is 2 power x over 1 minus 4 this dx. Always think how to remove a square root using trigonometric formulas. First, always check. If I change this into sine, because this is 4 and this is 2, I will change this into 2 square. Okay, and this will be equal to 2 power x. Okay, here 1 minus 2 power 2x, and here square root. Now this means you can write this one as equal to 2 power x over 1 minus 2 power x square and this dx. Okay, and now I want to remove square root using those ones trigonometric. Put 2 power x equal to sine theta, and then integral of this derivative of this is 2 power x remain at it is, and base is along 2 into dx, and this will be cosine theta d theta. Everything should change. Okay, 2 power x dx, with that will be 1 over ln 2 cosine theta d theta. Okay, this one will replace with this, and this will replace with this, and you will get equal to 1 over ln 2, and here you have cosine theta d theta, this value, and in the denominator you have 1 minus sine square theta, and this will be equal to 1 over ln 2 integral cosine theta over 1 minus sine square theta, that is cosine square theta square root. Okay, this will cancel with this, and you will left over only with cosine theta. I will write here cosine theta. This cosine cancel with this, 1 over ln 2. This will be integral of theta and d theta. Oh no, only d theta. D theta, right? And this will be equal to 1 over ln 2 theta plus c, and you will find theta from here by bringing sine inverse to that side, and the answer will be 1 over ln 2 sine inverse 2 power x plus c. This your sixth question, now last one, and that is similar one, 1 over 1 minus e power 2x dx. Okay, again you can put either sine or cosine. Usually is we use sine theta, and this you can write dx over 1 minus e power x square, and here square root. Put e power x equal to sine theta, you will get e power x derivative, differentiate with respect to theta, you will get dx over d theta. I will take other side, cosine theta d theta. That's the quickest way. And dx, that will be cosine theta d theta over e power x. I want to replace this. Dx will be cosine theta d theta over, you have sine theta, and this equal to integral cosine theta d theta over sine theta into 1 minus sine square theta. Okay, 1 minus sine square is cosine square, cosine theta d theta over sine theta into 1 minus sine square is cosine, and this cosine cancel with this one, and you left with integral cosecant theta d theta, because this is 1 over sine theta d theta, and you take this to the numerator, this sine, and that will be cosecant theta, and this integral is equal to log cosecant theta minus cotangent theta. You have to replace this with e power, right? I need sine everywhere, then I can do it. This is gone now, and this equal to log this cosecant, that will be 1 over sine, good, I got the sine, minus cosine theta over sine theta plus c. I will write this equal to log LCM 1 minus cosine theta over sine theta plus c, and this equal to log 1 minus, okay, cosine, I will write 1 minus sine square theta and over sine theta plus c. This equal to log 1 minus e power 2x over e power x. That's your answer. Thanks for watching. If you have more questions similar to this, you can write in the comments and I will solve for you.